Okay, let me go through some cool properties of right angle triangles now that we call soacahtoa. Okay, let me deal with the first one, right? Well, first off, let me split this up into three parts. But you remember it as soacahtoa, right? Basically, let me say we have this right angle triangle here. If I have an angle, let me say here, I can solve for any of these three things, whether it be the angle, whatever is opposite, the side that is opposite to the angle, or the hypotenuse, which is the angle opposite the right angle. That is what I'm telling you. I'm telling you I could solve for either one of these based off of this. And I'll show you how to solve for the angle, the opposite, and the hypotenuse now in three examples. Okay, so I have three examples here to show how this formula does work. The so part of soacahtoa. Alright, so in this one, they're asking you to solve for y. So let me first identify what we're working with. Remember, we're using so first, so it is sine of an angle is equals to opposite over hypotenuse. Let me identify these things now. So angle is 32. Let me just plug that into the formula one time. 32 opposite, which is the side of the triangle opposite to the angle, which is 6. The hypotenuse, which is the side opposite the right angle, which is y. We're solving for this now. This is just algebra from here at this point. So first you just compute sine of 32, which if you look here on your calculator, you'll see sine. So sine of 32 is 0.529 is equals to 6 over y. But we're trying to get y alone, right? So let me multiply everything by y. So we can get y out of the denominator here. So we get 0.529y is equals to 6 over y multiplied by y, which will give, cancel out this y, cancel out this y, so you're just left with 0.529 is equals to 6. 0.529y is equals to 6. So from here, we just divide both sides by 0.529 to just get y alone. So 0.529y over 0.529 equals to 6 divided by 0.529. This will cancel with this, so we're just left with y is equals to 6 over 0.529, which is 6. Where we get y is equals to 11.34. So we solve for y here. Let me move on to this question now, right? So formula is sine of an angle is equals to opposite over hypotenuse. Right? Let me input the values that we have. No, first let me identify what we have. So the angle is 15. So sine of 15. What is the opposite first? We see that is y. What is the hypotenuse? We see that is 8. So we're solving for y here. So sine of 15 is equals to 0.259 is equals to y over 8. So to get y alone, multiply both sides of the equation by 8. this 8, this 8 will cancel. So we're just left with y is equal to 8 multiplied by 0.259. 8 multiplied by 0.259. So we get y is equal to 2.072. Now for the last one here, let me input what we have into the formula again. Sine theta is equals to, well, theta is the angle, opposite over hypotenuse. So we have the angle y, sine y is equals to, we identify where's the opposite of the angle is 6. So 6 over hypotenuse, which is the opposite of the right angle, which is 7. So let's see, sine of y is equals to 6 divided by 7. 6 divided by 7 is 0.857. Right. But now we still have to solve for y.
No, it's better to solve for y as an angle. And that way you could teach them ABC how to do the angle one time. So sine inverse open bracket 6 ABC 7 close bracket. It's more accurate. Because you don't round off the decimal soon.
It's okay. It's okay. Alright, so we have sine of y is equals to 0.875. Right. So to get rid of the sign here now, what we have to do is we have to take the sine inverse of this side and this side. So basically, when you have sine inverse multiplied by sine of anything, when we just say a, we'll get the sine inverse and the sine cancels, so it will just be equals to a. So let me see now, let me apply this. Apply sine inverse to both sides of the equation, we'll get sine inverse of sine y is equals to sine inverse of 0.857. Sine inverse cancels with the sine, so you're left with y is equals to this. Now sine inverse you could just plug into your calculator. Where you have sine here, you just press second function and sine and you'll get sine inverse, well, on the sharp calculator. So sine inverse of 0.857 is equals to 58.98. Right. So that is how you get each of the variables which are missing from this function. Sine of the angle is equals to opposite over hypotenuse. That is the first part in soacahtoa. So we done with that first part. Alright, let's do the next part of soacahtoa. Now the ka, which is cos of an angle, is equal to the adjacent over the hypotenuse, right? That is a new word now, adjacent. So let me first tell you what adjacent is, right? So we already know the opposite is the side which is opposite to the angle that we are given. The hypotenuse is the side opposite to the right angle. Now the adjacent side is the side which has both the right angle and the angle in it. So you could identify which side is which based on these three things: opposite the angle; hypotenuse, opposite the right angle; adjacent, has both the right angle and the angle I work in it. Right. So what I'm telling you now is that if I am given either the length of the hypotenuse or the length of the adjacent or the angle theta here, if I'm given two out of those three things, I could solve for the third thing using this formula here. Right. We're gonna do three examples, same way like how we did it in first the saw, and yeah, that should help explain this one. Alright, so we have three examples here, and we gotta solve for the unknowns sides or angles, right? So we're using this formula here. So let me just write out the formula for each of these examples. First, we will plug in what we know, and then we will solve for what we had to solve for. So cos of an angle is equal to the adjacent over the hypotenuse, right? So let me see. We have the angle here, which is 31. So we see cos 31 is equal to the adjacent, which is angle, the side which contains both angles. So that is y over the hypotenuse, the side opposite the right angle, which is 6. We're trying to solve for y. And so when we first find out what is cos of 31, that turns out to be 0.87857 is equals to y over 6. Now to get y alone, we multiply throughout by 6, since it's divided by 6 on this side, so we get 6. 0.857 is equals to y over 6 multiplied by 6. Both of these 6's will cancel, and 6 multiplied by 0.857 is equals to 5.142, which is equals to y. So we solve for y here, which is 5.142. Alright, now for the second example, we first write the formula again. Cos of the angle is equals to the adjacent over the hypotenuse. So we input what we have from the given values. So we have the angle, which is 15. What is the adjacent? The adjacent is 7. Hypotenuse is y. So cos of 15 is 0.966, which is equals to 7 over y. Let's get y out of the denominator. So let me multiply throughout by y. So we have y multiplied by 0.966 is equals to 7 over y multiplied by y. This y cancels. So we get y multiplied by 0.966 is equals to 7. So to get y alone, we divide throughout by 0.966. So we'll get y 0.966 divided by 0.966. This cancels with this is equals to 7 divided by 0.966, which we get to be 7 divided by 0.966. We get y is equals to 7.246. So we solved for the hypotenuse here. Now for this one, let's plug in what we have again. Cos of the angle, which is y, is equals to the adjacent, which is 6, over the hypotenuse, which is 7. So the cos of y is equals to 6 over 7, which evaluates to be 0.857 p-doctors. So to solve for y here, we do cos inverse throughout. So the same way how sine inverse cancels with sine, cos inverse of cos of A will just give you A. So I forgot to show, this is how you find cos on the sharp calculator. Cos inverse is second. Alright, so I was saying cos inverse is second function cos. The same way how you find sine inverse. Also, I forgot to mention sine, cos, and tan are all functions. That is why in the calculator you put like cos of something or sine of something or tan of something. They are functions acting on somethings, and these somethings are angles. Right, I just wanted to make that clear. Right, so for we to find y here now, we had to take the cos inverse on both sides. So let me do cos inverse of cos of y is equals to cos inverse of 0.857. So the cos inverse cancels the cos. So we just have y is equals to, let me just solve that, cos inverse of 0.857 is equals to 31.019. Right? So we solve for either one of the variables here using the other two which are given. Alright, so we just have, I was saying, we just have tan of opposite over adjacent to do now. So that is tan of an angle is equals to the opposite over the adjacent. So it's following the same principles as the sine and the cosine of the angles in soacahtoa. Well, the properties, I should say, the laws, the rules, whatever. Yeah. So this one now, if we have the angle, if we have the opposite side, and if we have the adjacent side, well, what I meant to say was, if we have two out of those three things, then we could solve for the other using this formula. I think all you should understand what's going on based on the sine and the cosine and soacahtoa. So let me just get 3 examples to solve each of these and we'll continue. So I had 3 examples here. Now for like what we do in the soa and the car, we're gonna do the same thing for the toa. Right? We're just gonna take the values that we have, plug it into the formula. So let me try the first one here. So we have the angle. So tan of 31 is equal to the opposite, which is y, over the adjacent, which is 6. So to find y here, first let me work out this. So tan of 32, tan is another function you can find in the calculator. It will be right next to the sine and the cos. This is 0.601 is equals to y on 6. Now to get y alone here, because that is what we are solving for, we multiply throughout by 6. So we'll get 6 multiplied by 0.601 is equals to y over 6 multiplied by 6. The 6 is cancelled. So now we have y is equals to 6 multiplied by that, which works out to be 3.606. So we solved for y here using the other 2 values that we have. We move on to question 2 now. So let me plug in the values. Alright, so for the other 2 examples now, we plug in the values that we have into the formula. Where the formula is tan of the angle is equals to the opposite over the adjacent, right? Alright, so we have the angle tan of 15 is equals to the opposite, which is 7, over the adjacent, which is y. So the tan of 15 evaluates to be, tan of 15 is 0.268 is equals to 7 over y. Right? Now, right, so we to solve for y here, we multiply throughout by y. So we get y of 0.268 is equals to 7 over y multiplied by y. This cancel, so we left with y 0.268 is equals to 7. So now we divide throughout by 0.268, so we get y alone. So when we divide this side by 0.268, this 0.268 cancels, so we left with y equals to 7 divided by 0.268, which works out to be 7 divided by 0.268, 26.12. Right. So we solve for this y here. Now for this y here, we input the values that we have. So tan, the angle is y, is equals to the opposite, which is 7 over the adjacent, which is 6. So we work out 7 over 6, which is 1.67. We leave tan of y as tan of y. Now to get rid of the tan of y, we multiply throughout by the tan inverse of y, which is the same thing of like the sine and the cos, where tan inverse of tan of a will just give you a. So the tans will cancel. The tan inverse and the tan will cancel. So tan inverse of tan of y is equals to tan inverse of 1.67. So the tan inverse and the tan cancels. So you just be left with y is equals to tan inverse of 1.67, which gives you y is equals to 59.09. Right. So we just solved for all of the unknowns in the formula. Tan of angle is equals to opposite over adjacent, given only 2 out of these 3 options. Alright, so now that you know what soacahtoa is, you could use that for any right angle triangle you have, where they just give you two variables and one unknown variable, and it's just for you to plug in these variables into one of these formulas to solve for the other variables. So if you're given